So this one's a little bit backwards than the ones we've been doing so far. At this point, our farmer wants to enclose 1,500 square meters total. Okay? So now I'm telling you the area. Now there's going to be a little bit of fencing that we need to do this. So my question is, what's the least amount of fencing we can do it? So, like I told you before, the first thing we do is get a picture, which I gave you a picture right here. The farmer's using, this is a house here, so we don't have to fence off this section right there. Let me use a different color just so we're not all in red. Okay, we don't have to fence off this section. Cool. So the amount of fence that we're going to have to use is an L here, an L here, an L here. Look at all these L's. Okay, like a report card. And these are all W's. Also like a report card. There you go. Okay, so that's how much we have to fence off. They're all congruent, and we want to do 1,500 square meters. Okay, so remember, the first key thing, get an equation for what you're trying to optimize. In this case, it's not area like it was before. In this case, it's the amount of fencing. So I need an equation for the amount of fence. Well, the amount of fence I have to use to build this contraption here, if you're going to work, is 6 L's and 3 W's. That's what's going to build that. Okay? Now we're going to derive that equation. That's the whole point of this equation. We have to derive the thing we're trying to optimize, which means maximize or minimize. Okay? But we can't derive it the way it is. There's got too many variables in it. We're going to get rid of one using our restriction. Our restriction is at the area. So I'm going to finish this and put this online. If you want to hang out, you can. The area of that entire shape is 3L times W. Okay? This is my fixed equation. I'm going to use that to solve for one of those variables in there and drop it into this equation down here. Doesn't matter which one you want to solve for. I'm going to solve for W. Okay? And when you do that, you get the W is 500 over L. So whatever L is, W is going to be 500 over L. So that we get a 1,500 square foot area. And because W has to equal this, I'm just going to go ahead and drop it in right down here. Okay? Because again, the goal is to derive the fence equation. We want to find the minimum amount of fence. So W is becoming 500 over L. And we're going to simplify that. That's a plus there. To this. Okay? Now we have an equation for the amount of fence just given the length. If I told you the length was 10, you can plug it in and find how much fence we're going to need to get the area we want. Okay? But we're trying to derive this because we want to find the minimum amount of fence now. So the derivative of F with respect to L, look how easy this is 6 minus 1,500 over L squared. That's the power rule there. Because this is really 6L plus 1,500 L to the negative 1, right? So resume power rule there. And there's no DLDT or anything here. We're not driving with respect to time. We wonder where that's 0. Okay. So, it's just the wind. It's okay. Anytime you want to solve an equation, again, part fraction, part not fraction, you want to get a common denominator. Our common denominator is going to be L squared. So, good work, Sarah. So we're going to put L squareds there. We're going to multiply by L squared over L squared to get a common denominator. And that's going to give us this. 6L squared minus 1,500 over L squared is 0. You want that common denominator, kids. That's a big, big step for us here. Now, all I want to know is what makes that 0, what makes it undefined, just like we did before with all the f of x's. We set the top equal to 0. We set the denominator equal to 0. We get our critical values, and we make a number line to see where the minimum is. We want the least amount of fence. All right? So if the top is equal to 0, the numerator, we get this. If the denominator is equal to 0, we get this. So L equals 0 is a critical value. And if you solve this out, you can factor that if you want. You can divide by 6. You get L squared minus, what's 6 into 1500? 250? 250. Okay, and you can solve that, move the 250 over and take the square root. You get plus or minus the square root of 250, which is really plus or minus. My pen's going up or what? Plus or minus the, what comes out of there, 5? 5 root 10, okay? Now, because this is a length here, we don't care about that negative length. 5 root 10 is just some number. That's some amount of fence that we could use, okay? So we're going to make a number line for my derivative of the fence. And really, I'm just going to put a 0 here. I don't care about that negative 5 root 10. Like, it's there on the function. It's going to be a critical value on that graph of f. But it doesn't matter because f is the amount of fence. It can't be negative, okay? So the only number really going on here is 5 root 10. And remember what our derivative was, way up there. Look at all this work. If you drop a number, what's a number less than 5 root 10? Very good. 2, 1. Excellent. If you put 1, 2 into our derivative, which is right here, what kind of number are we going to get? It's a negative number. Great. If you put a number bigger than 5 root 10 in, like a million, you get that the derivative is positive. What that tells you is the amount of fence decreases as you make the fence, or the length go anywhere from 0 to 5 root 10. But once you cross that, the amount of fence is going to start increasing again. So the minimum amount of fence happens at 5 root 10. Okay? What's our question asked for? What's the minimum amount of fence? So we should really take that 5 root 10. Since it says what's the minimum amount of fence, we know what happens at 5 root 10. And again, you can get out here if you want. I know you want to go to lunch. We're going to plug 5 root 10 back into my fence equation. That's going to tell me how much fence I need. Okay, because that's what they asked me. How much fence, what's the least amount of fence? So I'm going to take 5 root 10 and drop it into this, my fence equation. And if you do that, you get the amount of fence we need is 6 times 5 root 10 plus 1500 over 5 root 10. And I'm going to simplify that down because I'm a nerd, and you should. If you had a calculator, this is just some decimal. But it's 30 root 10 plus 300 over root 10. Look how nice that is. And if you rationalize that, look at this. That's 30 root 10 plus 30 root 10. And that is 60 root 10 feet of fence. So if you want to close off all that area, you would need at least 60 root 10 feet of fence to do it.